So we have to do today midpoint theorem. Statement: the line segment joining the midpoints of any two sides. Statement: I told you the line segment joining the midpoints of two sides. The line segment joining the midpoints line segment joining the midpoints of any two sides of a triangle. Any two sides of a triangle is parallel to the third side. Is parallel to the third side and equal to half of it, and equal to half of it. I discussed this theorem in the previous class. Now we will prove the proof of this theorem. We have to do the proof of this theorem. So take a triangle. Suppose ABC, we have a triangle A and B. Okay, this is a triangle. And D and E are the midpoints of AB and AC. This is AB and AC. This is the midpoint, and this is the midpoint, the line joining the midpoints of AB and AC. So this is A, B, and C. And the midpoint of AB is D, and the midpoint of AC is E. And this is the line joining the midpoints and produce it to E, produce DE to F. Okay, this line DE is produced, DE line is produced, okay, is produced, and then join from C to this line such that CF is parallel to BA. This is BA. Then from C, draw a line which is parallel to BA. Parallel to BA. It is parallel to BA. Okay. So these two lines is can produce DE to F, and CF, this is parallel to BA. Okay, CF is parallel to BA. So our construction, before this we can write the construction. So what is our construction? First, we will do the construction. Huh? Construction. In construction, produce D E to F. E to F is produced up to F and draw CF parallel to BA. This is your construction. What we have to prove now, what we have to prove in this, we should write what we have to prove. To prove you have to prove that DE is parallel to DE is parallel DE is parallel to DE is parallel to BC and DE is equal to half of BC. Half of BC. Okay. So we will consider two triangle AED, this triangle AED, this triangle, okay, and another triangle CEF, CEF, this triangle, these two triangles. You see these two triangles, AE is equal to CE because this is the midpoint already given. AE is equal to CE, correct? AE is equal to CE. AE is equal to CE already given. Side. Then AED and CEF. This is angle 1, suppose, and this is angle 2. These are two vertically opposite angles are equal. So angle 1 is equal to angle 2. Then DAE, angle DAE, this angle number 3, suppose this is angle number 3, angle 3, and FCE, angle number 4. They are equal because CF is parallel to BA, therefore these are two vertically opposite angles. So therefore, alternate interior angles. They are alternate interior angles. So therefore, angle, side, angle. So we will consider these two triangles and we will show it first in triangle AED, in triangle AED, and the triangle CEF. CEF. We have angle, side, angle. So angle, side, angle. We should go in a sequence. Angle, side, angle. So first we can take angle 3 or angle 1. Any one angle we can take. So angle 1 is equal to angle 2. Why? Because they are vertically opposite angles. Vertically opposite angles are equal always. Then side AE is equal to AE is equal to CE. AE is equal to CE. It is given that E is the midpoint, so therefore we can write it as given that, or we can write E is the midpoint. both correct. And the third one, angle 3 will be equal to angle 4 cos ACF is parallel to BA, and 3 and 4 are alternate interior angles. So either you write CF is parallel, I think you should write CF is parallel to BA, and AC is the transversal, therefore alternate interior angles are equal. So interior alternate interior angles are equal. Are equal. Okay. So therefore by A as A congruency, we get triangle AED is AED is congruent to triangle CEF, congruent to triangle CEF. Okay, so this is our first, can say first step. From this, we can say that AD is equal to CF, AD is equal to CF, and DE is equal to EF. DE is equal to F by CPCT. These two triangles are congruent. So this shows that in these two triangles, AD is the side of the first triangle. So AD will be equal to CF by CPCT, and also DE is equal to DE is equal to EF. This is also by CPCT. These are the sides of the above triangles which are proved congruent. That's why. Okay. When these two sides are equal, but AD is equal to BD, AD is equal to BD, you can continue, but AD is equal to DB or BD. AD is equal to BD because D is the midpoint, and BD is equal to CF. BD will be equal to CF. Is the midpoint. So when AD is equal to BD, BD is equal to AD, and AD is equal to CF. So which shows that, here I am writing next. This shows that BD is equal to CF. Equal to CF. And BD is also parallel to CF. This is already BD parallel to CF. This is by construction. By construction, we have constructed the parallel line CF. So this is by construction. So when one pair is parallel and equal, so which implies that B, C, F, D is a parallelogram. Okay. When it is a parallelogram, then opposite sides are parallel. Therefore, DF is parallel to BC. DF is parallel to BC, and DE is also parallel. So when it is a parallelogram, so this says that DF is parallel DF is parallel to BC, and when DF is parallel to BC, DE will also parallel because DE is the part of the DF. So this implies that DE is also parallel to BC. So first we proved this one. We have to prove the two things. First thing, DE is parallel to BF. This is proved, first part. Now we have to prove that DE is equal to half of it. So opposite sides are parallel. Uh, After this, I'll put one star and here I will write on this corner. Okay. Now we have to prove that DE is equal to half of BC and DF is the side opposite to BC in a parallelogram. So you know that DE opposite sides are equal. So DF is equal to BC. Why? Because these are the opposite sides of a parallelogram. Opposite sides of a parallelogram are equal. And you can divide DF can be divided by 2. So we can write 1 by 2 of DF will be equal to 1 by 2 of BC. And 1 by 2 of DF, E is the midpoint because this is CPCT by CPCT. This is also equal to DE is also equal to EF by CPCT because these two triangles are congruent. Therefore, DF, half of DF will be equal to DE, correct? So this implies that half of DF will be equal to DE. Therefore, DE is equal to 1 by 2 BC. 1 by 2 BC. So this proves the second part, DE equal to 1 by 2. So this is the proof of theorem called midpoint theorem. So 8.2 exercise number 1. ABCD is a quadrilateral, PQRS at the midpoint. AC is the diagonal. Show that ACSR is parallel to AC and half of it. So you have seen that AP is the diagonal midpoint. So AP will be equal to PBQ is the midpoint of BC. So PQ will be equal to CQ, or you can use the two lines, and CR will be equal to DR, and this will be equal to this as given condition. Okay, we have to show that SR is parallel to AC. So in this triangle, by midpoint theorem, I'll do it fast. In triangle ADC by midpoint theorem, SR is parallel to AC because this is the midpoint. The line joining the midpoint is parallel to AC, and SR is equal to half of AC by midpoint theorem. Directly you can write by midpoint theorem. Second, PQ is equal to SR. You have to show that PQ is equal to SR. So PQ is equal to half of AC because PQ is the side of ABC. So PQ is equal to half of AC and SR is also half of AC. SR is equal to half of AC because SR is parallel, and similarly PQ is also equal to half of AC. So when these two are equal, this implies that PQ is equal to SR. So we have proved that PQ is equal to SR. Now we have to show that PQRS is a parallelogram. So PQ is parallel to AC. Also, PQ is parallel to AC because the line joining the midpoints parallel to AC. Similarly, SR is also parallel to AC. So this implies that PQ is parallel to SR and PQ is equal to SR when two sides are equal parallel. This shows that PQRS is a parallelogram. So this proves the third part. So this is the proof of this question. So we finished the first question. Again, you can see this we have seen actually. Which one we have seen? These two triangles we have seen. This triangle, this triangle above one, and this below one triangle, this below one triangle. Okay. So in this triangle, in these two triangles, these are the midpoints.